This is the second part of Lesson 3.2, Exponential Equations. The computer's value depreciates, and that word right there, that means that it goes down in value. So in other words, the value is decaying. So this is showing an exponential decay, and I know it's exponential because it's losing 40%, so the percent gives me a clue. This is not linear because we're dealing with a percent. Okay, so that's something you need to make sure that you understand. And it's depreciating 40% every 2 years, not every year, every 2 years. So that means that one time period is equal to 2 years. So in 1 year, what part of a time period would that be? So if you have 2 years as one time period, there's one time period, and so what would 1 year be? It would be a half of a time period. So what would x years be? That's going to be important because when you go to write your equation, you need to know what that is. So you're going to take whatever x is and you're going to divide it by 2. So wrap your head around that. Pause the video if you need to so that you can take a moment and digest that idea, but you need to be able to understand how to form a time period if it's different than every year, every month, every day, every hour. You need to know how to adjust. So on a previous problem we did where the time period was a half an hour, and so we said an hour was 2 time periods. This one is 2 years makes a whole time period. So that's one whole. And so this would only be a half of a time period. So think about that. Like I said, pause the video if you need to, but we're going to remember that because we have to write our equation. So I know it's decay. I know that my time is going to look like that. How many time periods are there in 1 year? There are half of a time period in 1 year. So the equation that we're going to write is going to look like y is equal to, what do I start with? What is the value at the beginning of the problem for this computer? So 1200. Okay, we know that it's decay, so how do I write an exponential decay problem? I'm going to start with 1 minus. Remember, the 1 starts with the value of 1200. It's 100% of what I had, and now I'm going to take away 40%. It would be wrong if you wrote 1200 times 0.40% or times 0.40 because that means that you just lost 60% of your value. So you got to make sure that you're looking at this from the right direction. And then for the exponent on this, we have to deal with our time period. And so this is where it becomes really important. If you just put x, that's going to be wrong. It's going to be x divided by 2. So when you put that in your calculator, you're going to type in 1200, and you can either type in 1 minus 0.4, or you can say, I know that that's 0.6, and then to the power of parentheses x divided by 2. If you don't put those parentheses in, it's going to give you a very different, very wrong answer. So that's our equation. We're going to use our equation now to fill in your table, and then you're going to graph this. Don't forget to label your x and y axis. Okay, make sure you label what is going to be on the x-axis, what's going to be on the y-axis. You're going to round your values in dollars, so to the nearest dollar, so no pennies. So take a minute and fill in the table, graph, label your axis, and then come back and let's just check and make sure you did it all right. Okay, so I started by labeling my x and y axis. So my x-axis is years. Remember that time is going to be your independent variable. My y-axis is how much value it has. I'm putting these numbers in, so I would just type in this equation that I have right here into my calculator. I'm just going to replace the x with the numbers. How many years have I put in? So 0 is obviously 1200, but then I'm going to put in 1, and then I can go back to the previous entry. I can just go back over the 1 and I can type a 2. And then I go back over that entry and I'm going to type a 3. And then I go back over that entry and I type a 4. And so I keep getting these numbers. Okay, so that's how I get the numbers in my table. I'm rounding all of these to the nearest dollar. So all of these I had to round to the nearest dollar. So I think about how much of a dollar is it. If it's more than half, then it goes up. And if it's less than half, it stays at the lower value. Okay, now going to graph this, I'm going to go ahead and graph each point, so each ordered pair. So I'm going to start this at 1200, and then I'm going to be going down. So after 2 years, make sure you pay attention. After 2 years, we're at 720. Okay, so don't go 930 right there. We're at 720 right here. So if I wanted to do my 930, that's going to be like right there. Okay, and then at 3 years, that's not on my graph. I can make it be on my graph, but 3 years would be at 558, so it's going to be about right there. And then 4 years is 432. So you can see that these numbers are going down. Okay, it dropped a lot that first year, and then it's dropping more, but it's not dropping as many dollars every year. And that's the really important thing to understand with exponentials, is you don't lose the same amount of dollars every year. Okay, you're losing the same percent, yes, but different amount of dollars. So as I get to 8 years, I'm at 156. As I get to 10 years, I'm at 93. And so do you start noticing how it's getting smaller and smaller, but it's never actually going to go to 0? Now you could type in 20 years. If you typed in 20 years here, what would you have? So you put it in your calculator and see, and you see that you're getting, at 20 years, you're down to like $7. Okay, now with a computer, nobody wants a computer for $7. It really is worthless. But even if you went more and more, it's going to be like smaller and smaller amounts of money, like maybe like 0.000001 cent. Well, that's not even a penny, but that's still something. And even if you go more and more, your calculator might start doing scientific notation. So if you see your calculator starting to do like 1.03e negative 10, that just means that the decimal is going to be going 10 places that way. And so again, it's practically worthless. It would round to 0, but it's actually still got value. And so that's where we start to see our asymptote happening. So this x-axis is actually our asymptote. It's the value that it's approaching, but it's never quite getting there. Now if I connect my dots, this is showing the value of the computer over time. Now in real life, probably nobody's going to go out and buy a computer that is 10 years old, because that would be stupid. But if we're following the pattern, okay, the equation is showing the pattern, so if it continues to follow that pattern, this is what's going to happen. In real life, like you would want a computer when it's brand new, so 0 years old, maybe a year or 2, okay? The last time I got my last school computer was in 2016, and when it was brand new supposedly, but when I got into the details of it, it was manufactured in 2013, so it was already like 3 years old. I was not very happy about that. But, I mean, it was brand new, nobody had used it, but it's just kind of old technology. So once you get past a couple of years, nobody wants that. Okay, so anyway, let's go to the last question, the last 2 questions. It says a form of beryllium, okay, if you know anything about chemistry, that's on your periodic table, has a half-life. Okay, if you remember on that very first page in your packet, and it says half-life is one of those special words with double, quadruple, and that just means that our rate, or our V, is equal to 1/2. That means I'm losing half every 15 seconds. So let's stop and think about it. If I have a clock, 15 seconds is 1/4 of it. So this is 15 seconds. In 1 minute, how many sets of 15 seconds are there? That's going to be 4 time periods. So if I look at this, I'm going to start with 12 grams, so that's my A. So let's write, we're going to have 12 times my B is 1/2. And I have to represent how much beryllium is there in grams after X minutes. So if I was to type in 1 minute, I'm talking about that whole minute right there. So how many time periods is that? How should I write my exponent? Should I just write 1x? Will that do it? If I do 2 minutes, how many time periods is that? So you've got to think about it. So 1 minute equals 4 times. 2 minutes would equal 8 times. So how do I write my equation so that I can have x minutes? What's going to happen? So I did 1 times 4, 2 times 4, so x times 4. That's how I'm going to write my exponent for my time periods. And remember, you're writing an equation. It has to have two sides. So that's my equation for how much beryllium is there after x amount of minutes. Okay, the last question, it's similar. It says, how much beryllium will there be after x seconds? So now I'm talking about, I'm going to input seconds. So I'm going to say, hey, Mr. Chemist, how much beryllium do you have? It's been 30 seconds. Okay, so I'm going to type that in. So how many time periods is 30 seconds? So we learned up here that 15 seconds was one time period. So what if I type in 30 seconds? How many time periods is that? If I type in 15 seconds, how many time periods is that? So I know 15 seconds is one time period. 30 seconds would be two time periods. So what would be x seconds? So what do I do to get time periods? I'm going to say 30 divided by what is 2? 15 divided by what is 2? So x divided by, 15 divided by what is 1? So x divided by, I'm going to do the same thing. I divided by 15. 30 divided by 15 is 2. 15 divided by 15 is 1. So I'm going to do x divided by 15. So when you're dealing with time periods, you have to stop and think, and you might have to make a little pattern like this and decide how many, because you have to be able to type in the units that it asks for. So here it's asking for seconds. So I'm going to take my 12 grams, 1/2, and I'm going to say x divided by 15. So let's think about that for a second. If I say it's been 3 minutes, I can't put in 3 right here because that's going to be in seconds. So that would be 3 seconds. So you have to make sure that you take into account the time periods. So if I say it's been 3 minutes, okay, how many seconds is that? So 3 minutes times 60 seconds, so that's 180 seconds. So I would type in 12 times 1/2 to the power of 180 divided by 15. And so that would take care of how many time periods that was. So 180 divided by 15, that's going to be 12. And so this is going to come out to be 12 time periods, and that's what I want. So that's how you would write an equation for that. And don't forget, equations have two sides. So this is my equation. So in this lesson, you have to worry about mostly the change in time periods. And so that's kind of the main thing that we're worried about here is time periods. So focus on, is it seconds or minutes or hours or pendulum swings, what's happening? So focus on that. It's going to affect your exponent. Also pay attention to, is it growth or decay? And so you're going to do 1 plus or minus the r. So that's the question. Which one are you going to do? And also remember that this 1 right there, that's for keeping what you have, and then you're going to add to what you have, or you're going to take away from what you have, because 100% is 1. So that's where that's all coming from. If you have any questions, make sure you ask and do your homework and come back with questions so that we can answer those.